Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 7 video on the chapter of mensuration where I will solve the last question, that is question number 10 from the concept practice problems set number 1. So these set number 1 problems were based on the area, perimeter, diagonal of a square, rectangle and the area of walls of a room. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the question 10 of concept practice problems set number 1. Okay, so I have the problem set. This was the concept problems practice problem set number 1. I have already solved question number 1 to 9 in the previous two videos. If you have not watched those two videos, then please do watch them. It will give you a good idea of how to solve this kind of problem on area, perimeter, diagonal of square and rectangle. Okay, so question number 10 are all has 5 parts. These are all true or false statements. Okay, so let's start. Question number 10, part 1 says, any increase in the perimeter of a figure always increases the area of the figure. Any increase in the perimeter of a figure always increases the area of the figure. Now, it is false, and I will prove that it is false by giving a counter example. That is, let's say increases the area of the figure. Okay, so let's say I am considering a rectangle. I'm sorry for my bad drawing. Please assume that this is a rectangle. Let's say the length is 10 centimeter and the breadth is 5 centimeter. I will try to manipulate the breadth and length, that is 5 centimeter and 10 centimeter, so that the effective perimeter will increase, but the area will not increase. So in this case, what is the perimeter? Perimeter is 2 into 5 plus 10, this much centimeter. Now, as you can see, as you know, that perimeter is, I'm considering, I'm giving a counter example with reference to a rectangle. So perimeter for a rectangle is 2 into length plus breadth. Now, if I want to increase the perimeter, definitely I have to manipulate the L and B such that effectively L plus B increases. But I will give a counter example. I will increase L and B in such a way. I will increase or decrease. I will manipulate L and B either by increasing or decreasing, so that effectively L plus B will increase. But L into B, area is L into B. L into B will decrease. So let's see. So in this case, perimeter is coming to be 30 centimeter. Okay, now area is 5 into 10 centimeter square, which is equal to 50 centimeter square. Okay, now let's say what if I make the rectangle, I manipulate the length and breadth so that the breadth I am decreasing by 2 centimeter, and remember that I have to manipulate the length and breadth in such a way that L plus B will increase, but L into B will decrease. So let's say I have decreased breadth by 2 centimeter, and let's say I will increase the length by 3 centimeter. Now you see the perimeter is 2 into 3 plus 13. which centimeter, which is equal to 32 centimeter. So perimeter has increased, but what about the area? The area is 3 into 13 centimeter square, which is equal to 39 centimeter square. So area has decreased. So I've increased the area by manipulating. So initially the rectangle was 5 centimeter and 10 centimeter. I've manipulated the length and breadth in such a way that the perimeter now is increased from 30 centimeter to 32 centimeter, and the area has decreased. Area initially was 50 centimeter square and now it is 39 centimeter square. So this is a counter example to say that any increase in the perimeter of a figure always increases the area of the figure. This is false. This is false. Okay. Let's do part 2. So always remember that for that increase in a perimeter of a figure does not always increase the area of the figure. Okay. Let's do part 2. Part 2 says that if both the length and breadth of a rectangle are doubled, then the area of the rectangle also gets doubled. So let's say initially, now what I don't know whether it will be true or false. So let's say initially let's say length be equal to L and breadth be equal to B. I'm not taking any units. I'm not taking any particular unit, so you can consider them as L units and B units. Okay. So initially length is L and breadth is B, and initially area A will be L into B, that is LB. Okay. Now after doubling, by doubling I mean after the length and breadth are doubled, the length is twice L and breadth is twice B, and the area A is twice L multiplied by twice B, which is 4LB. Now let's say, so we see that the area has become 4 times. Initially the area was L into B, and now after the length and breadth has been doubled, the area has become 4LB. So it is 4 times. So it is not doubled, but the area gets 4 times. If you double the length and breadth of a rectangle, the area gets increased by 4 times. So this statement is false. So this is a false statement. Okay. Let's do part number 3. Part number 3 says 2 figures can have the same area but different perimeters. 2 figures can have the same area but different perimeters. Yeah, I think this is true. 2 figures can have the same area but different perimeters. Now for a square, you know this, for a square this will be false, because for a square if the perimeters are same, the area has to be same, because a square has only one dimension, which is side. So if side is same, then perimeter and area will also be same. So let's consider again, let's see if this is true or not for a rectangle. 2 figures can have the same area but different perimeters. Okay. Same area but different perimeters. Okay. Okay. So basically this is breadth and this is L. So area in a rectangle is L into B. Now let's try to give some values to length and breadth, so that some different values to L and B such that L into B remains the same, but 2 into 2 perimeter is 2 into length plus B varies. That is, I am trying to give values to L and B, different values to L and B such that L into B is same, that is the area remains the same, but 2 into L plus B, that is L plus B will vary. Okay, let's see. Let's say let's fix the area. Let's fix the area. Let's say the area is let you can consider let area is 36 square units. Let area be 36 square units. Now, what values we can give to L and B such that L into B is 36. So we can have L as 9 and B as 4. So L into B is 36. In this case, if L is 9 and B is 4, the perimeter P will be 2 into 9 plus 4. This is 26. Perimeter is 26. And let's say L is let's say L is 6 and B is also 6, which becomes a square. Anyway, it does not matter. So this implies perimeter. So in this case, if L is 6, B is 6, the area is 36. If L is 9, B is 4, area is 36. For if L is 9, B is 4, perimeter is 26, and if L is 6, B is 6, we will see that the perimeter is 24. So the perimeters are different and the area is same. So this statement is true. That is, we can have figures such that they have the same area but different perimeters. Okay, part 4. It is saying that whether 10 centimeter square is equal to 100 meter square or not. Okay, 100 meter square or not, I think this is definitely false. This is definitely false, because what is 10 centimeter square? You must be very strong and familiar with the conversion of units for perimeter and area, that is from centimeter square to meter square, centimeter square, meter square, kilometer square, all these conversion from one unit to another. Now, what is 10 centimeter square? 10 centimeter square is 10 multiplied by centimeter square. Now, the easiest way, one way from to convert centimeter square to meter square is that. So you can consider, I don't know whether this will be mathematically correct way of explaining or not, but centimeter square you can consider as centimeter multiplied by centimeter. So this is 10 multiplied by, now what is 1 centimeter? What is now centimeter multiplied by 1 centimeter multiplied by 1 centimeter. Now what is centimeter? Centimeter in meter is how many meters is 1 centimeter? It is 1 by 100. So I can say this is 1 centimeter is meter, 1 meter, it is 1 by 100 meter, or rather centimeter is equal to 1 by 100 meter, and here I have multiplied by another centimeter, which is 1 by 100 meter. So this is 10 multiplied by, so 1 by 100 multiplied by 1 by 100 is 1 by 100 square, and I have meter multiplied by meter is meter square. So this is equal to 10 by 10 100 square meter square. So definitely this is not equal to 100 meter square. So this is a false statement. Okay, let's do the final part, part 5. The length of a lane 5 meter wide, which can be covered by 40,000 bricks of size 22 centimeter by 15 centimeter is 264 meter. The length of a lane, so there is a lane 5 meter wide, so the width of the lane is fixed, and its length is varying, it can change. Now the length of a lane 5 meter wide, which can be covered by 40,000 bricks of size 22 centimeter by 15 centimeter, is 264 meter. Now this means that we know the dimension of each brick. uh, Dimension of each brick is given to be 22 centimeter by 15 centimeter. Okay, uh, this means this means that area. So basically, the area of 40,000 bricks, where the dimension of each brick is given, the area of the 40,000 bricks has to be the same as the area of the lane 5 meter wide and some length, and that length we have to find. So the area of each brick is equal to 22 multiplied by 15 centimeter square, and this is equal to how much is 22 multiplied by 15? This is 330. So 330 centimeter square is the area of each brick. Okay, so area of 40,000 bricks, because the 40,000 bricks has to entirely cover the lane, will be equal to 40,000 multiplied by 330, this much centimeter square. Okay, so this is the area of 40,000 bricks. Now we have to find what will be the length of the lane. Let Now we have found the area of 40,000 bricks in centimeter square, but the dimension of the lane, the width of the lane, is given as in meter. So I think it is better that we convert the area of the 40,000 bricks from centimeter square to meter square. Now in the previous problem only, we have seen that centimeter square is equal to 1 by 100 square meter square. So this will be equal to 40,000 multiplied by 330 divided by 100 square, that is 100 multiplied by 100, this much meter square. So 0 zeros cancels out, this is equal to 1320 meter square. 4 multiplied by 330 is 1320 meter square. So the area of 40,000 bricks is 1320 meter square. Okay, so now let length of lane be x meter. So this implies area of lane will be equal to x multiplied by the width is given to be 5. So this much meter square, which is equal to 5x meter square. So this implies the area of the lane has to be equal to the area of the 40,000 bricks. So we must have 5x is equal to 1320. So this implies x is equal to 1320 divided by 5, this much meter. This is equal to 240 How much is this? 1320 divided by 5 is 264 meter. So the length of the lane has to be 264 meters. So this statement is true. This statement is true. Okay. So this brings to an end in solving the question number 10, which were true false statements. I hope solving these problems will give you a little bit insight and guidance and help as how to solve these kind of problems related to area perimeter of square and rectangle, and also diagonal of square rectangle and area of 4 walls of a room. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So I have solved all the problems of concepts practice problems set number 1 from the chapter of mensuration. Very soon I will prepare and release the concept practice problems set number 2, which will also be there will be less number of problems, but it will be based on the same topic, that is area perimeter diagonal of square rectangle and 4 walls of a room. And parallelly I will start the next topic from this chapter, which is area of, I guess, parallelogram and rhombus. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.